Hey everyone, welcome back to Sleepy Science. I'm so glad you're here with me today because we're about to dive into something that will completely change how you think about sleep. Imagine this. You're lying in bed, exhausted beyond words. Your body is screaming for rest. Your eyes burn. Your mind feels like it's wrapped in fog. But no matter what you do, you cannot fall asleep. Not tonight. Not tomorrow night, not ever again. And you know with absolute certainty that this inability to sleep is going to kill you. This isn't a nightmare. This happened to a real person. His name was Michael Cork, and in 1991, he became one of the most tragic cases in medical history. A man who literally could not sleep until his body gave up entirely. And if you're curious about the science behind sleep and want to learn how to protect your most precious biological function, hit that like button right now and subscribe to the channel. Trust me, by the end of this video, you'll understand why sleep isn't just important. It's the difference between life and death. Michael Cork was a 42-year-old music teacher from Chicago. By all accounts, he was healthy, active, loved by his students. But in the summer of 1991, something changed. He started having trouble falling asleep. At first, it seemed normal. Maybe stress, maybe anxiety. We've all been there, right? But this wasn't normal insomnia. Within weeks, Michael wasn't sleeping at all. 0 hours. His wife would watch him lie in bed, eyes wide open, staring at the ceiling all night long. His doctors were baffled. They tried every sleeping pill available, Ambien, Lunesta, heavy sedatives that would knock out a horse. Nothing worked. But here's what's truly terrifying. Michael wasn't just unable to sleep. He was deteriorating right before everyone's eyes. His body temperature became erratic, swinging wildly between fever and chills. He lost control of his tear ducts and started sweating uncontrollably. His pupils wouldn't respond to light anymore. He began having vivid, waking hallucinations, seeing things that weren't there, hearing voices that didn't exist. And then came the physical collapse. Michael lost nearly 40 pounds in just a few months. His speech became slurred, incoherent. He couldn't walk without assistance. His mind, once sharp and creative, began to fragment into confusion and terror. Imagine being trapped inside your own body, fully conscious, watching yourself fall apart piece by piece, knowing that sleep, the one thing that could save you, was impossible. 6 months after his symptoms began, Michael Cork died. The autopsy revealed something that would send shockwaves through the medical community. His brain showed massive damage to a tiny region called the thalamus, specifically, the area responsible for regulating sleep. Microscopic examination revealed something even more disturbing. Proteins in his brain had folded incorrectly, becoming toxic infectious agents that destroyed healthy brain tissue. These weren't viruses, they weren't bacteria, they were called prions. And they had sentenced Michael to death the moment they appeared. Michael Cork had fatal familial insomnia, or FFI. It's one of the rarest and most horrifying diseases known to medicine. Only about 40 families worldwide carry the genetic mutation that causes it. The disease is a death sentence with no cure, no treatment, and no escape. Once symptoms begin, patients have 6 months to 2 years before death. And here's what makes it truly nightmarish. You're conscious through almost all of it. Your body forgets how to sleep, but your mind remains painfully aware of what's happening. Let me explain what makes this disease so uniquely terrifying. Most of us think of sleep as simply rest. But sleep is actually one of the most complex biological processes your body performs. Your brain doesn't just turn off at night. It enters a carefully choreographed sequence of stages, each serving critical functions. During sleep, your brain clears out toxic waste products that accumulate during the day. It consolidates memories, repairs damaged cells, regulates hormones, and maintains your immune system. Sleep is when your body performs essential maintenance that cannot happen while you're awake. Fatal familial insomnia destroys the mechanism that initiates this process. The thalamus acts like a gatekeeper between wakefulness and sleep. When prions attack this region, they essentially jam the gate open. Your body tries desperately to sleep. You feel exhausted, your eyes close. You might even seem unconscious, but your brain never enters actual sleep. It's like trying to restart a computer that's frozen. The command is there, but nothing happens. What happens next is a cascade of biological failures. Without sleep, adenosine, a chemical that builds up in your brain during waking hours, never gets cleared out. It accumulates to toxic levels. Your neurons become hyperactive, firing erratically. You start experiencing what scientists call status dissociatus, a twilight state between waking and sleeping, where you experience the worst of both worlds. You hallucinate like you're dreaming, but you're conscious. You're exhausted, but cannot rest. Your body temperature regulation fails because the hypothalamus, which works closely with the thalamus, begins to malfunction. And here's something that haunts sleep researchers. Patients with FFI often enter what looks like sleep to outside observers. Their eyes close, they lie still. But EEG monitoring shows their brains remain in a waking pattern. They're trapped in their own minds, aware that they look like they're sleeping but feeling no actual rest. Imagine the psychological torture of that experience. You know you're dying because you can't sleep. You lie down. You close your eyes. Everyone tells you to just relax, but you literally cannot. Your brain has lost the ability to flip that switch. The progression of FFI follows a predictable pattern that's almost scripted by nature's cruelty. Stage 1. Insomnia begins usually in a person's 40s or 50s. They might think it's stress. Stage 2. Panic attacks and phobias develop as the brain's emotional regulation fails. Stage 3. Complete inability to sleep, accompanied by rapid weight loss and hallucinations. Stage 4. Dementia sets in as the brain damage becomes severe. The patient becomes unresponsive, their body shuts down, and death follows. Michael Cork's wife described watching her husband disappear before her eyes. He would tell her that he felt like he was falling through darkness, never hitting bottom. He said he could feel his mind slipping away but couldn't stop it. In his final weeks, he could no longer speak coherently. But his eyes showed full awareness of what was happening to him. Now, I need you to understand something crucial here. Fatal familial insomnia is extraordinarily rare. The chances of you having this disease are infinitesimally small. But here's why Michael Cork's story matters to all of us. It reveals what sleep deprivation actually does to the human body when taken to its absolute extreme. It's like studying a car crash in slow motion to understand the physics of impact. FFI shows us that sleep isn't optional. It's not a luxury. It's as essential to life as oxygen or water. Think about it. You can survive longer without food than you can without sleep. Hunger strikers have lasted over 60 days without eating, but nobody, and I mean nobody, has ever survived more than a few weeks of total sleep deprivation. Even in cases where people claim to have gone without sleep for extended periods, closer examination reveals they were experiencing micro-sleeps, brief moments where the brain essentially forces rest, even if you don't realize it's happening. But what about the rest of us? What about the millions of people who aren't suffering from FFI but are still chronically sleep deprived? Here's where Michael Cork's tragedy becomes a warning for modern society. While we won't die in 6 months from missing sleep, we are subjecting our bodies to the same biological processes that killed Michael, just in slow motion. Every night you shortchange yourself on sleep. You're experiencing a milder version of what he endured. Your brain struggles to clear waste. Your hormones become imbalanced. Your immune system weakens. Your neurons start misfiring. And the scariest part? Most people have no idea how sleep-deprived they actually are. We've normalized exhaustion. We've turned "I'll sleep when I'm dead" into a badge of honor. We brag about pulling all-nighters and surviving on 4 hours of sleep. But Michael Cork's story teaches us something that sleep scientists have been trying to tell us for decades. Sleep deprivation is not a sign of strength. It's a slow-acting poison. So, let me ask you something, and I want you to really think about this. When was the last time you woke up without an alarm clock, feeling truly refreshed? Not groggy, not reaching for coffee immediately, but genuinely rested. If you can't remember, you're not alone. Studies show that over 1/3 of American adults are chronically sleep deprived. And while we won't develop fatal familial insomnia, we are setting ourselves up for serious consequences. Because here's the truth that Michael Cork's case illuminates. Your body needs sleep the way it needs oxygen. You cannot negotiate with this biological necessity. You cannot train yourself to need less sleep. You cannot catch up on weekends and erase the damage of sleep deprivation during the week. The human body evolved over millions of years to require approximately 7 to 9 hours of sleep per night. That's not a suggestion. It's a biological imperative encoded in our DNA. But what exactly happens to our brains and bodies when we don't get enough sleep? What does science tell us about the cascade of effects that begin the moment we start shortchanging our rest? Michael Cork experienced the most extreme version of sleep deprivation possible. But all of us, to varying degrees, are playing with the same biological fire. The mechanisms that destroyed his brain in 6 months are the same mechanisms that chip away at our health every single night we fail to sleep properly. In the next part, we're going to dive deep into the neuroscience of sleeplessness. We're going to explore what happens to your brain after 24 hours without sleep, 48 hours, 72 hours, and beyond. We're going to look at one of the most extreme experiments ever conducted on sleep deprivation. A teenager who stayed awake for 11 days straight and what happened to his mind during that time. And I'm going to show you how being sleep deprived is scientifically equivalent to being drunk, with all the impairments that come with it. Because once you understand what lack of sleep actually does to your brain at the cellular level, you'll never think about skipping sleep the same way again. December 28th, 1963. A 17-year-old high school student named Randy Gardner made a bet with his friends. He claimed he could stay awake longer than anyone else. What started as a teenage challenge would become one of the most important sleep deprivation experiments in scientific history. 11 days, 264 hours without a single moment of sleep. And what happened to Randy's brain during that time reveals something absolutely terrifying about what's happening inside your head right now if you didn't sleep well last night. If you want to understand the hidden damage that sleep deprivation causes to your brain every single day, make sure you hit that like button and subscribe, because what I'm about to show you will change the way you think about staying up late forever. Let's start with something simple. What happens to your brain after just 24 hours without sleep? You might think you feel tired, maybe a bit foggy, but the reality is far more dramatic. Studies using functional MRI scans show that after one night without sleep, your prefrontal cortex, the part of your brain responsible for decision-making, impulse control, and rational thinking, experiences a significant reduction in activity. In fact, the impairment is equivalent to having a blood alcohol concentration of 0.1%. That's legally drunk in most countries. Think about that for a second. If you pulled an all-nighter to finish a project or study for an exam, your brain is functioning at the same level as someone who drank 4 or 5 beers. You wouldn't drive a car drunk, right? But millions of people drive to work every day after getting only 4 or 5 hours of sleep, completely unaware that their reaction times, judgment, and coordination are just as impaired. But here's where it gets really interesting. Your brain knows it needs sleep. It's screaming at you through a chemical messenger called adenosine. Every moment you're awake, adenosine builds up in your brain like pressure in a steam engine. The longer you stay awake, the more adenosine accumulates, creating what scientists call sleep pressure. This is why you feel progressively more tired as the day goes on. When you finally sleep, your brain clears out this adenosine, and you wake up refreshed. But what happens when you don't sleep? The adenosine just keeps building, and building, and building. Imagine a bathtub with the drain closed and the faucet running full blast. Eventually, it's going to overflow. That's essentially what happens in your brain. After 24 hours without sleep, adenosine levels are so high that your brain starts doing something desperate. It forces microsleeps on you whether you want them or not. Microsleeps are brief episodes, usually lasting between 1 to 30 seconds, where your brain essentially shuts down. Your eyes might be open. You might look awake, but parts of your brain have gone offline. Randy Gardner experienced these constantly during his 11-day ordeal. He would be in the middle of a conversation and suddenly stop talking, staring blankly ahead. His brain was stealing moments of rest without his permission. And here's the terrifying part. This happens to you too when you're sleep deprived. You just don't realize it. Studies of drowsy drivers show that microsleeps are responsible for hundreds of thousands of accidents every year. A driver will be cruising down the highway at 70 miles per hour, and for just 3 seconds, their brain goes offline. 3 seconds. That's enough time to travel the length of a football field completely unconscious. When they wake up, they often don't even realize they zoned out. They just suddenly find themselves veering off the road or rear-ending another car. Let's go deeper into Randy Gardner's experience because what happened to him illustrates the progressive deterioration of brain function with extended wakefulness. By day 2, Randy's eyes lost the ability to focus. His sense of smell disappeared entirely. By day 3, he became moody and uncoordinated. Simple tasks like touching his nose with his finger became difficult. His speech began to slur. Day 4 was when things got really strange. Randy started experiencing memory problems. He would forget what he was saying mid-sentence. He couldn't recall simple facts he'd known his entire life. When researchers asked him to count backwards from 100 by sevens, he stopped at 65, completely forgetting what he was supposed to be doing. But here's what's fascinating. When they reminded him, he could continue. The information wasn't erased from his brain. His brain just couldn't access it properly. It's like having a computer where the processor is glitching, but the hard drive is fine. By day 6, Randy began experiencing what neurologists call fragmented thinking. His thoughts would jump from topic to topic without connection. He would start talking about a baseball game and suddenly switch to discussing a completely unrelated memory from childhood, then jump to something else entirely. His brain was essentially short-circuiting. Day 8 brought something even more disturbing. Randy started having perceptual distortions. A street sign appeared to be a person. Shadows seemed to move and take on threatening shapes. His brain, desperate for the dream state it was being denied, began creating dreamlike hallucinations while he was still awake. The boundaries between waking and dreaming were breaking down. But the most revealing moment came on day 10. Researchers asked Randy to play a simple game. He had to press a button every time a number appeared on a screen. This is a task that requires minimal cognitive function. Just see a number, press a button. Randy couldn't do it. He would see the number and forget to press the button. Or he would press it multiple times. Or he would press it when no number was there. His brain had degraded to the point where even the most basic stimulus response function was failing. Now, here's what makes this truly alarming. Randy Gardner wasn't some medical anomaly. He was a normal, healthy teenager. What happened to him can happen to anyone who severely deprives themselves of sleep. In fact, it is happening to millions of people right now in a slower, less dramatic way. You see, you don't have to stay awake for 11 days to experience these effects. They happen incrementally every time you shortchange your sleep. Let me show you the timeline. After 16 hours of being awake, that's just a normal day for most people. Your cognitive performance starts to decline measurably. After 18 hours, your reaction time is impaired by about 50% compared to when you're well rested. After 20 hours, you're functionally equivalent to someone with a blood alcohol level of 0.08% legally drunk. And here's the kicker. Most people have no idea how impaired they actually are. Studies show that sleep-deprived individuals consistently overestimate their own performance. They think they're functioning normally when objective tests show significant deficits. It's called performance perception disconnect, and it's incredibly dangerous. You literally cannot trust your own judgment about how well you're functioning when you're sleep-deprived. But what's actually happening inside your brain at the cellular level during sleep deprivation? Let's zoom in. Your brain contains about 86 billion neurons, and these neurons communicate through electrical and chemical signals. When you're awake, your neurons are constantly firing, processing information, forming memories, controlling your body. This activity generates metabolic waste, toxic byproducts that accumulate in the spaces between your brain cells. In 2012, scientists at the University of Rochester made a groundbreaking discovery. They found that during sleep, your brain cells actually shrink by about 60%. This creates more space between cells, allowing cerebrospinal fluid to flow through and wash away the accumulated waste products. It's like your brain has a cleaning crew that only comes out at night. One of the most important waste products being cleared is beta amyloid, a protein that, when it accumulates, is strongly associated with Alzheimer's disease. When you don't sleep, this cleaning process doesn't happen. The toxic waste just sits there, building up day after day. Brain scans of chronically sleep-deprived individuals show significantly higher levels of beta amyloid compared to people who sleep well. This is one reason why poor sleep is now recognized as a major risk factor for dementia. You're essentially letting your brain marinate in its own toxic waste. But the damage doesn't stop there. Sleep deprivation also affects your neurons' ability to communicate effectively. A study published in Nature Medicine used electrodes implanted directly into the brains of epilepsy patients to measure neural activity. They found that when people were sleep deprived, their neurons fired more slowly and their signals were weaker. It's like trying to have a conversation on a phone with a bad connection. The information gets garbled and delayed. This explains why everything feels harder when you're tired. It's not just that you're sleepy. Your neurons are literally struggling to transmit information. Simple tasks require more effort because your brain has to work harder to overcome the sluggish neural communication. It's like trying to run through water instead of air. Now, let's talk about something that affects every single person watching this video: chronic partial sleep deprivation. Most people aren't pulling all-nighters like Randy Gardner. Instead, they're getting 6 hours of sleep instead of 8, or 5 hours instead of 7. They think, I'm still sleeping, just not quite enough. It's fine. But the research tells a very different story. A landmark study by researchers at the University of Pennsylvania had subjects sleep only 6 hours per night for 2 weeks. After just 14 days, their cognitive performance was equivalent to someone who had stayed awake for 24 hours straight. But here's the terrifying part. The subjects didn't feel that impaired. They reported feeling only slightly sleepy. Their brains had adapted to functioning in a degraded state, and they had no idea how much their performance had declined. This is called sleep debt, and it's cumulative. Every hour of sleep you miss adds to the debt. If you need 8 hours but only get 7, you've accumulated 1 hour of debt. Do that for a week, and you're 7 hours in the hole. Do it for a month, and you're carrying around the equivalent of an entire night's worth of missed sleep. And unlike financial debt, you can't just pay it back with one good night of rest. Recovery takes time, sometimes weeks of consistently good sleep to fully restore normal function. Let me give you a real-world example of how dangerous this chronic sleep deprivation can be. In 1986, the Space Shuttle Challenger exploded 73 seconds after launch, killing all 7 crew members. The investigation revealed that engineers had raised concerns about the O-ring seals and cold temperatures, but managers decided to proceed with the launch anyway. Why did they make such a catastrophic decision? Further investigation showed that key decision makers had been working under severe time pressure and were operating on inadequate sleep. Their impaired judgment, caused by sleep deprivation, contributed to one of the worst disasters in space exploration history. The Exxon Valdez oil spill in 1989, the third mate in charge had slept only 6 hours in the previous 48. The Chernobyl nuclear disaster in 1986, operators had been on duty for 13 hours straight. The pattern is clear. When humans are sleep deprived, they make mistakes, catastrophic mistakes. But you don't have to be operating a nuclear reactor for sleep deprivation to hurt you. Let me ask you this. Have you ever sent an email late at night and then regretted it the next morning? Have you ever gotten into an argument with someone you love because you were tired and irritable? Have you ever forgotten an important appointment or made a careless error at work? These are all symptoms of a sleep-deprived brain struggling to function normally. Here's something else that might shock you. Your immune system is intimately connected to your sleep. During deep sleep, your body produces cytokines, proteins that help fight infection and inflammation. When you don't sleep enough, your body produces fewer of these protective proteins. Studies show that people who sleep less than 6 hours per night are 4 times more likely to catch a cold when exposed to a virus compared to people who sleep 7 or more hours. And it's not just colds. Chronic sleep deprivation has been linked to increased risk of heart disease, stroke, diabetes, obesity, and even certain cancers. In fact, in 2007, the World Health Organization classified shift work involving circadian disruption as a probable carcinogen. That's right, not getting enough sleep at the right times might actually cause cancer. Your hormones go haywire too. After just one night of poor sleep, your body produces more ghrelin, the hormone that makes you feel hungry, and less leptin, the hormone that makes you feel full. This is why you crave junk food when you're tired. Your brain is desperately seeking quick energy because it's operating in crisis mode. Studies show that sleep-deprived people consume an average of 300 extra calories per day, mostly from high-fat, high-sugar foods. So, when you see someone who's chronically sleep-deprived and struggling with weight gain, mood problems, frequent illness, and poor performance at work, they're not lazy or weak. Their brain is literally being poisoned by accumulated metabolic waste. Their neurons are misfiring, their hormones are in chaos, and their immune system is compromised. They're fighting a biological war that they cannot win without sleep. Randy Gardner eventually slept after his 11-day marathon. He slept for 14 hours straight, then woke up feeling surprisingly normal. Follow-up studies over the years showed he had no permanent damage from the experience. His brain recovered. But here's the critical difference between Randy and most people today. Randy went through one extreme bout of sleep deprivation and then recovered. Most people today are living in a state of chronic, ongoing sleep deprivation that never ends. What Randy's experiment taught us is that the human brain is remarkably resilient, but only if you give it the chance to recover. The question is, are you giving your brain that chance? Or are you running up a sleep debt that's silently destroying your health, your relationships, and your future? But as terrifying as the science of voluntary sleep deprivation is, there's something even darker in human history. Because once people understood how devastating sleep deprivation could be, some decided to weaponize it. They turned the biological necessity of sleep into an instrument of torture so effective, so psychologically devastating, that it leaves no physical scars but can break a human mind in days. What happens when sleep deprivation isn't an accident or a choice, but a deliberate act of cruelty designed to destroy a person's sanity? In 1947, a Hungarian cardinal named József Mindszenty was arrested by the Soviet secret police. 39 days later, he appeared at a show trial, confessing to crimes he never committed, speaking in a monotone voice, his eyes vacant and hollow. He looked like a different person, a broken shell of the man who had once defied Stalin. What happened to him in those 39 days? He wasn't beaten. He wasn't starved. He wasn't physically tortured in any conventional sense. He was simply kept awake. And that alone was enough to shatter his mind so completely that he would confess to anything, believe anything, become anything his captors wanted him to be. If this darkness fascinates and horrifies you the way it does me, hit that like button and subscribe, because we're about to explore why sleep deprivation became known as the white torture, the cruelest weapon that leaves no marks but destroys everything that makes you human. The use of sleep deprivation as torture isn't new. Historical records suggest it was used in ancient China, medieval Europe, and by the Spanish Inquisition. But it was the Soviet Union in the 1930s and 1940s that perfected it into a systematic science. They understood something that modern neuroscience has only recently confirmed. Depriving someone of sleep doesn't just make them tired. It fundamentally rewires their brain, making them vulnerable to manipulation, suggestion, and psychological disintegration. Soviet interrogators developed a method they called the conveyor. Prisoners would be interrogated in shifts by fresh interrogators working in rotation. The prisoner never got to rest. As soon as they showed signs of falling asleep, they would be shaken awake, doused with cold water, or forced to stand. This would continue for days, sometimes weeks. The results were devastatingly effective. Prisoners would sign confessions to crimes that were physically impossible. They would implicate friends and family members. They would believe, genuinely believe, in their own guilt for things they never did. But why does this work? Why is sleep deprivation so much more psychologically destructive than other forms of torture? The answer lies in how sleep deprivation attacks the very foundation of human consciousness. When you torture someone physically, through beatings, electric shocks, or other brutal methods, the victim's sense of self remains intact. They know who they are. They know what's true and what's false. They're suffering, but their identity is preserved. Sleep deprivation is different. It doesn't attack your body. It attacks your mind's ability to distinguish reality from fiction. Let me explain the mechanism. Your brain's prefrontal cortex, the region responsible for executive function, reality testing, and maintaining a coherent sense of self, is exquisitely sensitive to sleep deprivation. After just 3 days without sleep, this region begins to show significant dysfunction on brain imaging studies. The connections between the prefrontal cortex and other brain regions start to break down. Your brain loses its ability to filter information, to separate important from trivial, real from imagined, memory from suggestion. At the same time, your amygdala, the brain's fear and emotion center, becomes hyperactive. Brain scans show that sleep-deprived individuals have up to 60% more activity in the amygdala compared to well-rested people. This creates a state of heightened emotional reactivity. Everything feels more threatening. Every question from an interrogator feels more urgent. Every suggestion becomes more believable. You're experiencing the world through a lens of fear and confusion that makes you desperate for relief. Any relief, even if it means confessing to crimes you didn't commit. The Soviet psychologists understood this intuitively. They knew that after about 5 days without sleep, a prisoner would enter what they called the breaking point. At this stage, the prisoner would begin to hallucinate, but not in the dramatic way you might imagine. These weren't vivid visions. Instead, prisoners reported a kind of waking dream state where they couldn't tell if they were asleep or awake, if events were happening or had happened before, if the interrogator was real or a figment of their imagination. One documented case from the Stalin-era purges describes a prisoner who, after 7 days without sleep, began to believe that his interrogator was his father. He started confessing family secrets from his childhood, mixing real memories with fabricated ones, unable to distinguish between past and present. When he was finally allowed to sleep and later shown the transcript of his confession, he had no memory of saying any of it. The person who made that confession felt like a stranger to him. But the Soviets weren't the only ones to weaponize sleep. During the Korean War, Chinese and North Korean forces used sleep deprivation on American prisoners of war with devastating effectiveness. Captain Claude Batchelor, an American POW, eventually made propaganda broadcasts for the North Koreans and chose to stay in China after the war ended rather than return home. When he finally did return and faced court-martial, psychiatrists examining him determined that extended sleep deprivation had been a primary tool in his indoctrination. His personality had been so fundamentally altered that even years later, he struggled to reconnect with his pre-captivity identity. The Chinese approach was particularly insidious. They combined sleep deprivation with something they called thought reform. Prisoners would be kept awake and subjected to endless study sessions where they had to critique their own thinking, confess to capitalist thoughts, and embrace communist ideology. The sleep deprivation made their brains highly suggestible, while the repetitive indoctrination took advantage of this vulnerability. It's like trying to reprogram a computer when its antivirus software is disabled. The prisoner's critical thinking, their mental firewall, was offline, allowing new beliefs to be installed directly. Now, fast forward to the early 2000s. After September 11th, the CIA developed what they euphemistically called enhanced interrogation techniques for use on terrorism suspects. One of the primary techniques was sleep deprivation. Detainees at facilities like Guantanamo Bay and CIA black sites around the world were subjected to prolonged periods without sleep, sometimes lasting over a week. They would be shackled in stress positions, exposed to loud music or white noise, and subjected to temperature extremes, all designed to prevent sleep while technically avoiding the legal definition of torture. Declassified CIA documents revealed they understood exactly what they were doing. Internal memos cited the same Soviet research from the 1950s. They knew that sleep deprivation after 96 to 180 hours would produce significant decrements in cognitive performance and increased suggestibility. They knew they were attacking the prisoner's ability to think clearly, to maintain their sense of reality, to resist interrogation. One detainee, Khalid Sheikh Mohammed, was subjected to 180 hours, 7.5 days, of continuous sleep deprivation. He was kept in a standing position in a diaper, shackled to the ceiling. Anytime his legs buckled and he started to fall, guards would prop him back up. Music blasted constantly. Bright lights stayed on 24 hours a day. By the end, he was hallucinating, incoherent, and confessing to involvement in plots that investigators later determined he couldn't possibly have been part of. Here's what makes sleep deprivation such an effective and cruel torture. It's completely deniable. You're not hitting anyone. You're not cutting them. You're not even touching them most of the time. You're just not letting them sleep. To an outside observer, especially one without understanding of the neuroscience, it doesn't look that bad. The prisoner is just being kept awake. They're not bleeding. There are no broken bones, no visible scars. But the psychological damage is profound and lasting. A study of torture survivors conducted by the Center for Victims of Torture found that individuals who had been subjected to sleep deprivation showed rates of PTSD, depression, and cognitive impairment comparable to or exceeding those who had experienced severe physical torture. Many reported ongoing sleep disorders years after their release. Their brains had been so traumatized by the experience of forced wakefulness that normal sleep became difficult or impossible. Dr. Alan Keller, a physician who has examined dozens of torture survivors, describes sleep deprivation as one of the most devastating forms of torture, precisely because it attacks the victim's sense of reality. He's documented cases where survivors, years after their ordeal, still struggle to trust their own memories and perceptions. The boundary between what's real and what's imagined was so thoroughly dissolved during their torture that it never fully recovered. Think about what this means. Your sense of self, your personality, your memories, your beliefs, your very identity, all of it depends on your brain functioning normally. And your brain cannot function normally without sleep. Sleep deprivation doesn't just make you tired. It doesn't just impair your performance. It fundamentally alters who you are at the most basic level. There's a reason the United Nations Convention Against Torture now explicitly classifies prolonged sleep deprivation as a form of torture. The evidence is overwhelming, but here's what should terrify you. The difference between torture-level sleep deprivation and what millions of people voluntarily do to themselves every night is only a matter of degree, not kind. The mechanisms are the same. The damage is the same. It just happens more slowly. When an interrogator keeps a prisoner awake for 5 days to break their will, we rightfully call it torture. But when someone voluntarily sleeps only 4 or 5 hours a night for months or years, their brain is undergoing the same fundamental assault. The amygdala becomes hyperactive. The prefrontal cortex deteriorates. The ability to regulate emotions, think clearly, and maintain a stable sense of self erodes. The only difference is time scale. Let me give you a concrete example. A 2013 study published in the journal Sleep examined the brains of medical residents, doctors in training who routinely work 30-hour shifts with minimal sleep. Brain scans showed patterns of neural activity strikingly similar to those seen in clinical depression. The residents' emotional regulation was compromised. Their stress response was chronically elevated. Their cognitive performance was impaired. They were experiencing, in a very real sense, a form of self-inflicted psychological damage. And here's the most disturbing parallel. Just like torture victims, chronically sleep-deprived individuals often don't recognize how impaired they are. They've adapted to a degraded baseline. They think they're functioning normally. They believe they're making rational decisions. But objective measures show profound deficits. Their brains have been compromised, and they lack the very mental faculty needed to recognize that compromise. The interrogators in Soviet prisons understood something we've forgotten in modern society. They knew that sleep isn't a luxury or a weakness. It's the foundation of human cognition and identity. Attack sleep, and you attack everything. Destroy someone's ability to sleep, and you destroy the person themselves. So let me ask you something, and I want you to really consider this. If we recognize that forcing someone to stay awake for days is torture, if we understand it's cruel and inhumane, why do we treat our own voluntary sleep deprivation as normal? Why do we glorify overwork and celebrate people who survive on 4 hours of sleep? We're doing to ourselves, slowly and voluntarily, what torturers do to prisoners deliberately and rapidly. The prisoners in Soviet camps, in North Korean facilities, in CIA black sites, they had no choice. Sleep was taken from them by force. But most of us, we're giving it away freely. We're choosing to subject our brains to the same neurological assault that breaks prisoners and destroys minds. The torture chambers were designed to exploit a biological vulnerability. We've just renamed that vulnerability productivity and made it a virtue. But knowing that sleep deprivation can be weaponized, that it can break minds and shatter identities, only tells us part of the story. Because when someone is truly deprived of sleep for extended periods, something even stranger begins to happen. The boundary between waking and dreaming doesn't just blur, it completely dissolves. And what emerges is a nightmare landscape where reality itself becomes questionable, where your own mind turns against you, where the world transforms into something alien and terrifying. This is where we're headed next, into the psychological abyss that opens when the human brain is pushed beyond its breaking point. January 1959, Times Square, New York City. A glass booth sits in the middle of one of the busiest intersections in the world. Inside, a radio DJ named Peter Tripp has been awake for over 100 hours, broadcasting live while thousands of people watch. He's attempting to break the world record for continuous wakefulness to raise money for charity. But on day 6, something goes terribly wrong. Peter looks at his desk and sees flames erupting from the drawer, even though there's no fire. He sees cobwebs covering the ceiling that aren't there. When a doctor arrives to examine him, Peter becomes convinced the man is an undertaker coming to bury him alive. Peter Tripp's mind has begun to disintegrate, and what happens next reveals something absolutely terrifying about what your brain does when it's denied the dream state it desperately needs. If you want to understand why your brain creates nightmares in broad daylight when you don't sleep, smash that like button and subscribe, because we're about to journey into the strangest territory in neuroscience, the place where waking and dreaming collide and reality becomes optional. Peter Tripp's Wake-a-thon was supposed to be a publicity stunt. Instead, it became one of the most documented cases of extreme sleep deprivation psychosis in medical history. Psychiatrists and neurologists monitored him around the clock, recording every change in his mental state. And what they witnessed was like watching a human mind slowly come apart at the seams. For the first 72 hours, Peter seemed relatively normal. Tired, certainly. Irritable, yes. But functional. Then, around hour 90, something shifted. He started making mistakes during his broadcast, calling people by wrong names, forgetting what song he had just played, losing his train of thought mid-sentence. His producers thought he was just exhausted, but the doctors monitoring him recognized the signs. Peter's brain was beginning to dream while he was still awake. Here's what makes this absolutely fascinating from a neuroscience perspective. Your brain doesn't just want to dream. It needs to dream with an urgency that rivals your need for oxygen. During REM sleep, when most vivid dreaming occurs, your brain is actually more active than when you're awake. It's consolidating memories, processing emotions, and performing critical maintenance on your neural networks. When you deny your brain this essential function, it doesn't just give up and wait. It forces the dream state to intrude into waking consciousness. Scientists call this phenomenon REM intrusion, or dream state breakthrough. Brainwave studies of severely sleep-deprived individuals show something remarkable. Their EEG patterns start displaying characteristics of both waking and REM sleep simultaneously. Parts of their brain are trying to dream, while other parts are trying to stay awake. It's like your brain is attempting to run two incompatible programs at the same time, and the result is a kind of mental static that manifests as hallucinations, delusions, and perceptual distortions. By hour 120, Peter Tripp's hallucinations became more frequent and more bizarre. He opened a drawer and saw it filled with spiders. He looked at a scientist's tweed suit and became convinced it was made of writhing worms. He saw the clock on the wall melting like a Salvador Dali painting. But here's what's crucial to understand. Peter didn't think he was hallucinating. To him, these experiences were completely real. His brain had lost the ability to distinguish between internally generated imagery and external sensory input. This is fundamentally different from hallucinations caused by psychedelic drugs. When someone takes LSD or psilocybin, they usually maintain some awareness that they're hallucinating. There's a part of their consciousness that can observe and recognize the altered state. But with sleep deprivation, that metacognitive awareness disappears. The hallucinations are seamlessly integrated into the person's experience of reality. A research team at Harvard Medical School has studied this phenomenon using functional MRI. They found that in sleep-deprived subjects experiencing hallucinations, the visual cortex shows activation patterns identical to those seen during actual visual perception. In other words, when Peter Tripp saw spiders, his visual cortex was processing the image of spiders as if they were genuinely present. The hallucination wasn't happening in his imagination. From his brain's perspective, it was happening in the real world. But Peter's visual hallucinations were just the beginning. On day 7, his personality began to fragment. He became paranoid, convinced that the doctors monitoring him were trying to harm him. He accused his producer of conspiring against him. He became aggressive and hostile toward people he'd known for years. The psychiatrist supervising the experiment noted that Peter was exhibiting symptoms indistinguishable from acute paranoid schizophrenia. This raises a profound question. Was Peter Tripp going insane? Or was this a temporary state caused by sleep deprivation? The answer reveals something crucial about the nature of mental illness itself. Many psychiatric conditions, including schizophrenia, involve disruptions to sleep architecture. Patients with schizophrenia often show abnormal REM sleep patterns. Some researchers now believe that at least some symptoms of psychosis may be caused by, or exacerbated by, the brain's inability to properly separate the dream state from waking consciousness. Think about the core symptoms of schizophrenia. Hallucinations, delusions, paranoia, confused thinking. These are the exact same symptoms that appear in extreme sleep deprivation. The difference is duration. In sleep deprivation, the symptoms resolve with sleep. In schizophrenia, they persist. But the underlying mechanism, the brain's confusion about what's real and what's internally generated, may be fundamentally similar. Peter Tripp's experience also revealed something else remarkable. Around hour 160, he began experiencing what neurologists call micropsia and macropsia, perceptual distortions, where objects appear either much smaller or much larger than they actually are. He looked at a medical researcher and saw him as a giant towering over the room. A moment later, the same person appeared tiny, like a miniature figurine. His brain's ability to process spatial relationships and size constancy had completely broken down. But perhaps the most disturbing phase came around hour 180. Peter began to lose his sense of identity. When he looked in a mirror, he didn't recognize his own face. He became convinced he was someone else. He started referring to Peter Tripp in the third person, as if discussing a different individual. His very sense of self, the foundation of consciousness, was dissolving. Neuropsychologists call this depersonalization, and it represents one of the most profound effects of extreme sleep deprivation. Your sense of being a continuous, unified person depends on proper functioning of brain networks connecting your prefrontal cortex, temporal lobes, and parietal regions. Sleep deprivation disrupts these connections. The result is a terrifying experience where you can observe yourself from outside, where your own thoughts and actions feel foreign and disconnected, where the basic experience of "I am me" becomes questionable. After 201 hours, 8 days and 9 hours without sleep, the experiment finally ended. Peter Tripp slept for 13 hours, then woke up. Physically, he seemed fine, but something had changed. Friends and family reported that Peter was different after the experiment. He became more prone to depression. His marriage fell apart. His radio career declined. Some close to him said he never fully recovered his pre-experiment personality. This raises a haunting possibility. Can extreme sleep deprivation cause permanent psychological damage? The medical literature suggests it can, at least in some cases. Brain scans of individuals who've experienced prolonged severe sleep deprivation sometimes show lasting changes in brain structure and function. The hippocampus, crucial for memory formation, can shrink. White matter integrity, the neural cables connecting different brain regions, can be compromised. The damage may be partially reversible, but some effects appear to linger. Now, you might be thinking, I'll never stay awake for 8 days straight, so this doesn't apply to me. But here's where it gets personal. The hallucinations and perceptual distortions we're talking about don't only happen at extreme levels of sleep deprivation. They happen in milder forms with moderate sleep deprivation too. You've probably experienced them yourself without recognizing what they were. Have you ever been driving late at night, exhausted, and seen something dart across the road that wasn't there? That's a REM intrusion. Have you ever been up late studying or working and heard someone call your name, but when you looked, no one was there? That's an auditory hallucination caused by sleep deprivation. Have you ever felt like you were being watched or sensed a presence in the room when you were alone at night after inadequate sleep? Your brain, desperate for the dream state it's being denied, is creating brief dream-like experiences in your waking consciousness. A study conducted at the University of Bonn in Germany found that even moderate sleep restriction, just 5 hours of sleep for several nights, can cause measurable perceptual distortions. Subjects reported seeing objects move that were stationary, hearing sounds that weren't present, and feeling physical sensations that had no external cause. The researchers used eye-tracking technology and found that sleep-deprived subjects' eyes would fixate on empty spaces, suggesting their brains were processing visual information that wasn't there. But there's another type of hallucination associated with sleep deprivation that's even more common and potentially more dangerous: the experience of shadow people. Thousands of people, when severely tired, report seeing dark, humanoid figures in their peripheral vision. When they turn to look directly, the figures vanish. This phenomenon is so consistent across cultures and individuals that it suggests a specific neurological mechanism. Researchers believe shadow people are caused by the brain's pattern recognition system malfunctioning under sleep deprivation. Your visual cortex is constantly trying to make sense of the world, looking for familiar patterns. especially faces and bodies which have evolutionary significance. When sleep-deprived, this system becomes hyperactive and error-prone. It starts seeing faces in random visual noise, finding human forms in shadows and peripheral blur. The amygdala, also hyperactive due to sleep loss, tags these false detections as threatening, creating the eerie sensation of being watched or followed by dark figures. This isn't just a curiosity. It has real-world consequences. Truck drivers, who often suffer from chronic sleep deprivation, report seeing phantom pedestrians or animals on the road, causing them to swerve dangerously. Night shift workers describe seeing colleagues who aren't actually there. Security guards on long shifts report shadowy figures that trigger false alarms. These aren't supernatural experiences. They're your brain's attempt to dream while your eyes are still open. There's also a phenomenon called microsleep hallucinations that's particularly dangerous. Remember microsleeps? Those brief moments where your brain forces rest on you? During these episodes, which can last just seconds, you might have vivid dreamlike experiences. To you, it feels like you blinked and suddenly something changed about your environment. You might wake up from a microsleep and be confused about where you are or what you are doing. Drivers experiencing this might suddenly find themselves in a different lane or realize they've traveled several miles with no memory of the journey. But perhaps the most philosophically troubling aspect of sleep deprivation hallucinations is what they reveal about the nature of reality itself. We tend to think of reality as something out there that our senses passively report. But neuroscience tells a different story. Your brain is constantly constructing a model of reality based on sensory input, prior expectations, and internal states. What you experience as the world is actually a simulation generated by your brain, calibrated by sensory information, but fundamentally created internally. Sleep deprivation reveals how fragile this simulation is. When your brain's operating system is compromised, the simulation starts breaking down. Objects that should be stationary appear to move. Faces appear in random patterns. Spaces seem to expand and contract. And the most unsettling part? You have no way of knowing from inside the experience what's real and what's hallucinated. Your confidence in what you're seeing is completely disconnected from the accuracy of your perception. Peter Tripp's experience in that glass booth in Times Square showed us something profound and disturbing. The boundary between sanity and madness, between perception and hallucination, between self and other. These aren't fixed walls. They're thresholds that depend on your brain functioning normally. And normal brain function requires sleep. Deny sleep, and those boundaries dissolve. The world becomes unstable. Your mind becomes untrustworthy. Reality itself becomes negotiable. So here's what I want you to consider. If missing sleep for a week can make you hallucinate, lose your sense of identity, and experience reality as fluid and unreliable, what is chronic long-term sleep deprivation doing to your perception of reality right now? Are you seeing the world accurately? Are your thoughts your own? How would you even know if the answer was no? But the psychological disintegration we've explored, the hallucinations, the paranoia, the fragmentation of self, these are symptoms of what sleep deprivation does to your mind. What we haven't discussed yet is what it does to your body. Because while your brain is drowning in toxic waste and conjuring phantom images, your immune system is collapsing, your DNA is being damaged, and your organs are beginning a slow process of systemic failure. The body may not hallucinate, but it has its own way of screaming that something is catastrophically wrong. In 2002, a healthy 38-year-old Chinese man named Chen Qingdong set out to prove he could watch every match of the World Cup without sleeping. For 11 days, he stayed glued to his television, consuming massive amounts of caffeine and energy drinks to stay awake. He made it through the tournament. He saw every goal, every penalty, every dramatic moment. And then, 36 hours after the final match ended, Chen Qingdong died. The autopsy revealed something shocking. His body had essentially attacked itself. His immune system had collapsed so catastrophically that a combination of infections and systemic inflammation killed him. The doctors concluded that extreme sleep deprivation had transformed his own biology into a weapon against his survival. If understanding how sleep deprivation wages war on your body from the inside out matters to you, hit that like button and subscribe, because we're about to explore the invisible battlefield inside your body, where the absence of sleep triggers a cascade of biological failures that can literally kill you. Let's start with something that affects every single person watching this: your immune system. Right now, as you sit here, your body is fighting off countless threats: bacteria, viruses, abnormal cells that could become cancer, toxins, parasites. Your immune system is a 24-hour defense force working to keep you alive. But this defense force has a critical dependency. It requires sleep to function properly. Without sleep, your immune system doesn't just weaken. It actively malfunctions in ways that make you vulnerable to disease and death. Here's how it works. During deep sleep, your body produces and distributes cytokines, proteins that are essential for fighting infection and inflammation. These cytokines act like communication signals, coordinating your immune response and directing immune cells to areas of threat. But the production of these crucial proteins is tightly linked to your sleep cycle. Miss sleep, and you miss out on cytokine production. A groundbreaking study conducted at the University of Chicago in 2009 demonstrated this with brutal clarity. Researchers took healthy volunteers and restricted them to 4 hours of sleep per night for 6 nights. Then they gave them a flu vaccine. Normally, a flu vaccine triggers robust antibody production. Your body creates defenders against the virus. But in the sleep-deprived subjects, antibody production was less than 50% of normal levels. Their immune systems, starved of sleep, couldn't mount an adequate defense even when directly challenged with a vaccine. But it gets worse. Another study, published in the Journal of the American Medical Association, tracked over 20,000 people over several years, monitoring their sleep habits and health outcomes. The results were staggering. People who consistently slept less than 6 hours per night were 4 times more likely to catch a cold when exposed to a virus compared to those who slept 7 or more hours. 4 times. That's not a small difference. That's the difference between a robust immune system and one that's barely functioning. Now you might think, okay, I'm more likely to get a cold. That's not ideal, but it's not catastrophic. But we're not just talking about colds. We're talking about your body's ability to fight all pathogens, including potentially deadly ones. Studies of healthcare workers during infectious disease outbreaks show that those with chronic sleep deprivation have significantly higher infection rates, longer illness duration, and more severe complications. During the COVID-19 pandemic, research found that healthcare workers averaging less than 6 hours of sleep were 70% more likely to contract the virus compared to those getting adequate sleep. Let me explain the cellular mechanism here, because it's absolutely fascinating and terrifying. Your immune system relies heavily on cells called T cells and natural killer cells. These are like special forces soldiers in your immune army. T cells identify and destroy infected cells. Natural killer cells hunt down and eliminate cancer cells and virus-infected cells. During sleep, particularly during deep sleep, these cells circulate through your lymph nodes and tissues, getting trained and activated to recognize threats. Research published in the Journal of Experimental Medicine showed that a single night of sleep deprivation reduces natural killer cell activity by up to 70%. 70%. Imagine if your home security system suddenly became 70% less effective. That's what's happening to your body's defense against cancer and infections every time you don't get adequate sleep. But here's where it becomes truly alarming. Chronic sleep deprivation doesn't just reduce immune function temporarily. It actually reprograms your immune system at the genetic level. Scientists at UCLA studied the gene expression patterns in white blood cells of sleep-deprived individuals and found something disturbing. Genes associated with inflammation were upregulated, becoming more active. Meanwhile, genes associated with immune function were downregulated, becoming less active. This creates a dangerous paradox. Your immune system becomes simultaneously overactive in harmful ways and underactive in protective ways. It's like having security guards who ignore actual threats but constantly set off false alarms. This state of chronic low-grade inflammation is called inflammaging, and it's associated with virtually every major disease of aging: cardiovascular disease, diabetes, Alzheimer's, cancer, and autoimmune disorders. Let's talk about cardiovascular effects specifically because they're immediate and deadly. When you don't sleep enough, your sympathetic nervous system, your body's stress response, stays activated. Your heart rate remains elevated. Your blood pressure doesn't dip the way it should during nighttime hours. Over time, this constant cardiovascular stress literally damages your blood vessels. A meta-analysis published in the European Heart Journal examined data from over 1 million people across 15 studies. The conclusion was unequivocal. People who sleep less than 6 hours per night have a 48% increased risk of developing or dying from coronary heart disease and a 15% increased risk of stroke. These aren't small numbers. We're talking about nearly doubling your risk of the #1 cause of death in developed countries. The mechanism is brutal in its simplicity. Your blood vessels have an inner lining called the endothelium. This lining is supposed to be smooth and flexible, allowing blood to flow easily. But chronic sleep deprivation causes inflammation that damages this lining. Damaged endothelium becomes rough and sticky, attracting cholesterol and immune cells. This is how atherosclerotic plaques form, the foundation of heart attacks and strokes. Even more immediate is the effect on blood pressure. Normally, your blood pressure should drop 10 to 20% during sleep. This is called dipping, and it's essential for cardiovascular health. It gives your blood vessels and heart a chance to recover from the stress of the day. But people who don't sleep enough don't experience this dip. Their cardiovascular system is under constant pressure, like a car engine running at high RPMs 24 hours a day. Eventually, something breaks. A study of Japanese workers found that those sleeping less than 5 hours per night had more than 5 times the risk of developing hypertension compared to those sleeping 7 to 8 hours. And we're not talking about people with pre-existing conditions. These were healthy individuals whose only major risk factor was inadequate sleep. Now, let's discuss something that terrifies me personally: the relationship between sleep and cancer. Your body produces cancerous cells every single day. This is normal. Cell division occasionally goes wrong, creating mutated cells with the potential to become tumors. What prevents cancer from developing in most people is your immune system's constant surveillance and destruction of these abnormal cells. But this cancer defense system is heavily dependent on sleep. In 2003, the World Health Organization's International Agency for Research on Cancer made a stunning announcement. They classified shift work involving circadian disruption as A probable carcinogen. Think about what that means. Working at night, which inevitably disrupts sleep, was placed in the same category as certain chemical exposures and radiation. The evidence was simply too overwhelming to ignore. Studies of female nurses working night shifts showed a 36% increased risk of breast cancer for those working nights for more than 15 years. Flight attendants who experience constant circadian disruption have double the rate of breast cancer compared to the general population. Men working permanent night shifts have a 3 times higher rate of prostate cancer. The mechanism relates to a hormone called melatonin. Melatonin isn't just a sleep aid you can buy at the pharmacy. It's a powerful antioxidant and tumor suppressor produced by your pineal gland during darkness. Melatonin helps repair DNA damage, inhibits tumor growth, and enhances immune function against cancer cells. When you don't sleep properly, especially when you're exposed to light at night, melatonin production plummets. Your body loses one of its most important cancer defense mechanisms. But there's an even more direct pathway. During deep sleep, your glymphatic system, the brain's waste clearance system, flushes out beta amyloid and other toxic proteins. When this doesn't happen, these proteins accumulate. Recent research has shown that chronic elevation of certain waste products can damage DNA and cells throughout the body, increasing mutation rates and cancer risk. Let's shift to metabolism, because this affects everyone regardless of whether they work night shifts. When you don't sleep enough, your body's ability to regulate blood sugar is compromised. After just 4 nights of sleeping only 4.5 hours, healthy young adults showed glucose metabolism patterns resembling pre-diabetes. Their cells became resistant to insulin, the hormone that helps move sugar from blood into cells. A study tracking over 60,000 women over 16 years found that those sleeping 5 hours or less per night had a 34% increased risk of developing type 2 diabetes, even after controlling for diet, exercise, and body weight. Sleep deprivation creates a metabolic environment that promotes diabetes development independent of other risk factors. The reason is multifaceted. Sleep deprivation increases cortisol, your stress hormone, which raises blood sugar. It decreases leptin, the hormone that signals fullness, and increases ghrelin, the hormone that signals hunger. This hormonal chaos makes you crave high-calorie foods while simultaneously making your body less able to process those calories effectively. You end up in a vicious cycle where you eat more, your metabolism works less efficiently, and your risk of obesity and diabetes skyrockets. Here's a personal question for you. Have you noticed that when you're tired, you crave junk food? That's not a character flaw or lack of willpower. That's your biology screaming for quick energy because your hormonal regulation is disrupted. Studies using brain imaging show that sleep-deprived individuals have increased activity in the amygdala, the brain's reward center, when shown images of high-calorie foods. Your brain, running on insufficient sleep, literally becomes more responsive to unhealthy food cues. Now, let's discuss something even more fundamental. DNA damage. Every cell in your body contains DNA, the instruction manual for life. This DNA is constantly being damaged by normal metabolic processes, environmental toxins, and radiation. Normally, your cells have repair mechanisms that fix this damage, particularly during sleep. But sleep deprivation impairs these repair processes. A study published in the journal Anesthesia examined the DNA of doctors after a single night shift. Just 1 night of sleep deprivation caused measurable increases in DNA strand breaks in their white blood cells. These breaks, if not repaired, can lead to mutations, cellular dysfunction, and increased cancer risk. Chronic sleep deprivation means chronic DNA damage, accumulating over time, increasing your risk of genetic diseases and accelerating aging at the cellular level. The effects extend to your skin, which is often called a window into internal health. Studies show that chronic sleep deprivation accelerates skin aging, impairs wound healing, and reduces the skin's ability to recover from environmental stressors like UV exposure. People who sleep poorly show twice the number of fine lines and wrinkles and significantly more uneven pigmentation compared to good sleepers. This isn't vanity. It's a visible marker of systemic biological deterioration. Your gut health suffers too. The bacteria living in your intestines, your microbiome, plays crucial roles in digestion, immune function, and even mental health. Research shows that sleep deprivation alters the composition of your gut microbiome, reducing beneficial bacteria and increasing harmful species. This dysbiosis is associated with inflammatory bowel diseases, metabolic disorders, and even depression. One particularly disturbing study looked at the relationship between sleep duration and all-cause mortality, basically, death from any cause. Analyzing data from over 1.3 million people across 16 studies, researchers found a clear pattern. People sleeping less than 6 hours per night had a 12% increased risk of death compared to those sleeping 7 to 8 hours. But here's what's interesting. Sleeping more than 9 hours was also associated with increased mortality risk, suggesting that both too little and too much sleep can be harmful, though the mechanisms differ. What's happening in Qin Qingdong's case, the man who died after watching the World Cup, was an extreme version of what happens to everyone who doesn't sleep enough. His immune system, overwhelmed by the accumulated damage and unable to produce the protective factors it needed, essentially gave up. Infections that his body would normally fight off easily became overwhelming. Inflammation spiraled out of control. His organs began failing in a cascade that couldn't be stopped. But here's what should keep you up at night, if that weren't ironic. You don't need to stay awake for 11 days for these effects to manifest. They're happening to you right now, in smaller increments, every time you shortchange your sleep. Every night you get 5 hours instead of 8, your immune system weakens. Your DNA accumulates a bit more damage. Your cardiovascular system experiences a bit more stress. Your cancer surveillance system becomes a bit less effective. And these effects are cumulative. Think about it this way. If someone told you there was a pill that would reduce your immune function by 70%, increase your risk of heart disease by 50%, double your diabetes risk, and accelerate cancer development, you would never take it. You would consider it poison. But that's exactly what chronic sleep deprivation does to your body. The only difference is that it works slowly, invisibly, without immediate obvious symptoms, so we ignore it. The body that never sleeps isn't just tired. It's being systematically destroyed from within by its own compromised biology. But as devastating as this widespread biological collapse is, there's an even more horrifying possibility. What if the inability to sleep wasn't a choice? What if it was genetic? An inherited death sentence that ran in families, activated at a certain age, and killed with absolute certainty. This nightmare isn't hypothetical. It's real, it's rare. And what it teaches us about the absolute necessity of sleep will fundamentally change how you think about every night you close your eyes. Venice, Italy, 1765. A wealthy merchant begins experiencing strange symptoms at age 43. He stops sleeping. Within months, he's dead. His son develops the same condition at age 42, dies within a year. His grandson, same age, same symptoms, same outcome. For over 200 years, this Italian family watched as generation after generation was claimed by an invisible curse that struck without warning in midlife, stealing sleep first, then sanity, then life itself. In 1983, two scientists finally discovered what was killing them: a single mutation in a single gene, creating misfolded proteins that act like infectious agents, destroying the sleep centers of the brain with absolute certainty and zero chance of survival. This is fatal familial insomnia, and it's the most terrifying proof that sleep isn't optional. It's the difference between life and death written into our very DNA. If understanding the darkest truth about sleep's absolute necessity interests you, please hit that like button and subscribe, because we're about to explore a disease so rare and so horrifying that it reveals the fundamental importance of sleep in ways nothing else can. The Italian family I mentioned is real. They're known in medical literature only by a pseudonym to protect their privacy, but their tragedy has taught science more about the necessity of sleep than perhaps any other case in history. For generations, family members lived normal lives until middle age, when the insomnia would begin. At first, it seemed like ordinary sleeplessness, maybe stress, maybe anxiety. But then it would progress with terrifying inevitability through 4 distinct stages that always ended the same way. Stage 1 typically lasts about 4 months. The patient develops progressive insomnia. They're still able to function, though they're increasingly exhausted. They try sleeping pills, meditation, therapy. Nothing works. Their brain has lost the ability to initiate sleep, and no external intervention can restore it. Brain scans during this stage show the beginning of damage to the thalamus, specifically the anterior and dorsomedial nuclei, the regions responsible for regulating sleep-wake cycles. Stage 2 brings panic attacks and phobias. The patient becomes hypervigilant, paranoid, and profoundly anxious. This isn't psychological, it's neurological. The damage to the thalamus is spreading, affecting emotional regulation and the autonomic nervous system. Patients experience intense sympathetic activation, their fight-or-flight response stuck in the on position. Heart rate becomes irregular. Sweating becomes profuse and uncontrollable. Body temperature fluctuates wildly. The patient is trapped in a state of perpetual physiological terror. Stage 3 is where complete sleep loss occurs. The patient hasn't slept at all for months now. They begin losing weight rapidly, often dropping 30 to 40 pounds. Hallucinations become constant. They can no longer distinguish reality from delusion. Their movements become jerky and uncoordinated. They develop what neurologists call aneric stupor, a twilight state where they appear to be enacting dreams while technically awake. They might gesture at invisible objects, have conversations with people who aren't there, or perform elaborate pantomimes of daily activities. Stage 4 is the final descent. The patient becomes completely unresponsive, though their eyes remain open. They're locked in a state between waking and sleeping, belonging fully to neither. Dementia sets in rapidly. They lose the ability to speak, to recognize loved ones, to control basic bodily functions. Within weeks or months, they die. The average time from first symptoms to death is 18 months, though some patients deteriorate more quickly. The disease is caused by a mutation in the PRNP gene on chromosome 20. This gene codes for a protein called PRP, prion protein. Normally, this protein exists in a harmless form throughout your body, particularly in your brain. But the mutation causes the protein to misfold into an abnormal shape. And here's where it becomes nightmarishly unique. These misfolded proteins are infectious. Prions aren't viruses or bacteria, they're just proteins. But misfolded prions have a terrifying property. They can force normally folded prions to misfold like themselves. It's like a zombie converting other cells. One misfolded prion contacts a normal prion and causes it to change shape. Now, there are 2 misfolded prions. These contact more normal prions, creating an exponential cascade. The misfolded prions aggregate into clumps that are toxic to neurons, particularly in the thalamus. What makes prion diseases uniquely horrifying is that they're essentially untreatable. You can't use antibiotics because they're not bacteria. You can't use antivirals because they're not viruses. You can't use chemotherapy because they're not cancer. They're just proteins that are the wrong shape, and we have no way to refold them or stop them from spreading. Once the cascade begins, it's irreversible. Fatal familial insomnia is inherited in an autosomal dominant pattern. This means if you inherit the mutation from even one parent, you will develop the disease. There's no carrier state. If you have the gene, you will get the disease. The penetrance is 100%. Everyone with the mutation who lives long enough will develop symptoms, typically between ages 30 and 60, with an average onset in the late 40s. Currently, fewer than 40 families worldwide are known to carry the FFI mutation. The total number of people at risk is estimated at around 200, but every single one of those 200 people knows they're living under a death sentence. They know that sometime in midlife, they'll stop sleeping, and they know that when that happens, they have less than 2 years to live. Imagine being 25 years old and knowing this. You've watched your mother die from FFI. Your grandmother died from it. Your great-grandfather died from it. You have a 50% chance of carrying the mutation. Would you want to get tested? This is a question that families with FFI face, and there's no right answer. Some choose to get genetic testing to know for certain. Others refuse, preferring to live without the knowledge until symptoms appear. For those who test positive, the psychological burden is immense. You're healthy, young, full of life, but you know that in 20 years, maybe less, your brain will begin to destroy itself. You'll lose the ability to sleep, then your mind, then your life, and there's nothing you can do to stop it. No diet, no exercise, no medication, no lifestyle change will alter your fate. One case that's particularly well documented involved a man I'll call Silvano from the Italian family mentioned earlier. Silvano knew his family history. He'd watched relatives die from the disease. When he reached his 50s, he started documenting his symptoms, working with researchers in the hope that his death might contribute to finding a cure. His detailed diary and medical records provide an unprecedented window into the subjective experience of FFI. Silvano described the initial insomnia as feeling like my brain forgot how to turn off. He would lie in bed, exhausted beyond description, but no matter how long he kept his eyes closed, sleep wouldn't come. He tried every sleeping medication available. None worked. He tried sedatives so powerful they should have rendered him unconscious. His body would relax, his eyes would close, but his brain remained stubbornly awake. As the disease progressed, Silvano developed what he called a constant feeling of emergency. His autonomic nervous system was in permanent overdrive. He sweated constantly, soaking through multiple shirts a day. His heart raced even when sitting still. He described feeling like he was perpetually running from danger, even though intellectually he knew there was no threat. This wasn't anxiety in the psychological sense. It was his dying thalamus sending constant panic signals to his body. The hallucinations terrified him. He would see his deceased relatives standing in doorways. He would hear music playing that wasn't there. Objects would appear to move and transform. But the most disturbing part, he wrote, was that he couldn't tell when he was hallucinating. The false perceptions were seamlessly integrated into his experience of reality. Only later, when he described events to his wife and she gently corrected him, would he realize that what he'd experienced wasn't real. In his final months, Silvano lost the ability to write coherently, but video recordings show him going through elaborate pantomimes. He would mime drinking from an invisible cup, having conversations with empty chairs, reaching for objects that didn't exist. Researchers believe his brain was attempting to dream, to discharge the built-up need for REM sleep. But because he couldn't actually enter sleep, these dreamlike behaviors spilled into his waking state. Silvano died 6 months after his first symptom. The autopsy confirmed what researchers expected: massive destruction of the thalamic nuclei, with dense deposits of misfolded prion proteins. His brain tissue was riddled with sponge-like holes where neurons had died. The regions controlling sleep were completely destroyed. Research into FFI has revealed something profound about the nature of sleep itself. Sleep isn't just a state of rest that we can do without if necessary. It's an active, essential biological process that clears toxic waste from the brain, regulates hormone production, maintains immune function, and preserves neurological integrity. Without it, the brain literally destroys itself. Scientists have tried everything to save FFI patients. They've tried every sleeping medication known to medicine. They've tried anesthesia, rendering patients completely unconscious for hours. Remarkably, even under general anesthesia, FFI patients' brainwaves don't show normal sleep patterns. Their brains remain in a wake-like state even when they're unconscious. The specific neural circuits that generate sleep have been destroyed. And unconsciousness is not the same thing as sleep. One experimental approach involved using a medication called gamma-hydroxybutyrate, which can induce slow-wave sleep. It provided temporary relief for one patient, giving them a few hours of something resembling sleep. But the effect diminished over time as the disease progressed, and ultimately, it couldn't stop the inevitable deterioration. The tragic reality is that once FFI symptoms begin, nothing can stop the progression. No medication, no surgery, no intervention can restore the brain's ability to sleep once the thalamus is damaged beyond a certain point. Patients and their families can only watch as the disease follows its predetermined course. But FFI teaches us something crucial about the relationship between sleep and survival. It demonstrates that sleep is not a luxury or a waste of time. It's as essential to life as oxygen or water. Humans can survive longer without food than we can without sleep. And when we voluntarily deprive ourselves of sleep through our modern lifestyle, working long hours, staying up late on screens, sacrificing rest for productivity, we're subjecting ourselves to a milder version of what kills FFI patients. The difference is time scale. FFI kills in months because the sleep loss is total and the brain damage is catastrophic. Chronic partial sleep deprivation kills over decades through accumulated wear on the cardiovascular system, weakened immunity, increased cancer risk, and accelerated neurodegeneration. But the fundamental mechanism is the same. Sleep is necessary for survival, and without adequate sleep, the body begins to fail. One question that haunts researchers: could we all, in theory, develop something like FFI through extreme sleep deprivation? The answer appears to be no. FFI kills because it destroys the brain structures that initiate sleep. Even if you tried to stay awake forever, your brain would eventually force micro-sleeps on you. The worst-case scenario for voluntary sleep deprivation is what we discussed earlier: severe cognitive impairment, hallucinations, and eventual recovery with sleep. You can't voluntarily destroy your thalamus the way prions do. But here's what should concern you. While most of us won't develop FFI, many of us are developing other neurodegenerative diseases that are linked to chronic poor sleep. Alzheimer's disease, for instance, is strongly associated with sleep disruption. The same toxic proteins that accumulate in Alzheimer's, beta, amyloid, and tau, are normally cleared during deep sleep. Chronic sleep deprivation allows these proteins to build up, potentially accelerating Alzheimer's development. In fact, Some researchers now believe that the relationship between sleep and neurodegeneration is bidirectional. Poor sleep increases the risk of Alzheimer's, but early Alzheimer's also disrupts sleep, creating a vicious cycle that accelerates cognitive decline. It's not identical to FFI, but it shares the underlying principle. Without adequate sleep, the brain cannot maintain itself. For families affected by FFI, there's a glimmer of hope on the horizon. Researchers are working on treatments that might stop prion propagation or protect neurons from prion toxicity. Some experimental therapies have shown promise in animal models, but as of now, no effective treatment exists for humans. The disease remains 100% fatal. Living with the knowledge of FFI in your family must be an almost unbearable burden. But these families have contributed enormously to science. By participating in research, donating tissue samples, and documenting their experiences, they have helped us understand the absolute necessity of sleep. They have shown us that sleep is not optional, not negotiable, not something we can compromise on without consequences. So when you're tempted to stay up late, to push through exhaustion, to treat sleep as something that can wait, remember the families like Silvano's. Remember that sleep is so important that your DNA includes instructions for making it happen every single night. And remember that when those instructions fail, the result is death. Fast, inevitable, and absolute. But while FFI represents the most extreme and rare form of fatal insomnia, the truth is that millions of people are suffering from a much more common epidemic of sleeplessness. Not from a genetic mutation, but from the modern world we've created. A world of screens and shift work, of 24-hour productivity and artificial light, where sleep has become optional and rest is seen as weakness. This widespread sleep crisis is creating a public health disaster that's hiding in plain sight, affecting 1 in 3 adults and slowly eroding the health and well-being of entire populations. In 1910, the average American slept 9 hours per night. By 1950, that number had dropped to 8 hours. Today, in 2025, the average is 6 hours and 31 minutes, and falling. We've lost over 2.5 hours of sleep per night in just over a century. That's 17.5 hours per week, 70 hours per month, nearly 900 hours per year. If you're 30 years old, you've already lost 27,000 hours of sleep compared to what your great-great-grandparents got. That's over 3 years of your life that your brain and body desperately needed, but never received. And this isn't happening by accident. We've systematically engineered a world that makes sleep nearly impossible, and we're paying a price that most people don't even realize they're accumulating. If understanding how modern life is stealing your health through sleep deprivation one night at a time matters to you, hit that like button and subscribe, because we're about to expose the invisible epidemic that's affecting 1 in 3 adults and destroying our collective health in ways we're only beginning to understand. Let's start with the most obvious culprit: artificial light. For hundreds of thousands of years, human biology evolved in sync with the sun. When darkness fell, our brains released melatonin, the hormone that makes us sleepy. When dawn broke, melatonin production stopped and cortisol rose to wake us up. This cycle, called the circadian rhythm, is fundamental to human health. But then, in 1879, Thomas Edison invented the practical light bulb and everything changed. At first, electric light just extended the day a bit. People stayed up an hour or two later. Not ideal, but manageable. But in the past 20 years, we've added a new dimension to artificial light. Screens, your phone, laptop, tablet, television, all emit blue light at wavelengths between 450 and 480 nanometers. This specific wavelength is detected by photoreceptors in your eyes called intrinsically photosensitive retinal ganglion cells. These cells send signals directly to your brain's master clock, the suprachiasmatic nucleus, telling it, "It's daytime, stay awake." A study from Harvard Medical School compared the effects of reading a book versus reading on an iPad before bed. The iPad users took an average of 10 minutes longer to fall asleep, had significantly reduced melatonin levels, and experienced less REM sleep. But here's the disturbing part. Even when they did fall asleep, their sleep was lighter and less restorative. The next morning, they felt groggier and took longer to achieve full alertness. 1 hour of screen time before bed delayed their circadian rhythm by an hour and a half. Think about your own habits. When was the last time you went to bed without looking at your phone? When was the last time you didn't check your email or social media right before trying to sleep? For most people, the answer is never. We've trained ourselves to end every day by blasting our brains with the light signal that means stay awake. And then we wonder why we can't sleep. But screens are just part of the problem. Let's talk about something that affects over 21 million Americans: shift work. Working nights or rotating shifts fundamentally disrupts your circadian rhythm in ways that create serious health consequences. Your body expects to be awake during the day and asleep at night. This isn't cultural or learned, it's genetic. Every cell in your body contains clock genes that regulate metabolism, hormone production, and cellular repair on a roughly 24-hour cycle. When you work nights, you're forcing your body to operate against this genetic programming. A comprehensive study published in the Proceedings of the National Academy of Sciences examined the gene expression patterns of shift workers. They found that working nights disrupts the normal rhythmic expression of over 1,000 genes. These genes control everything from immune function to metabolism to DNA repair. Essentially, shift work throws your entire biology into chaos. The health consequences are devastating. Shift workers have a 40% increased risk of cardiovascular disease. Their risk of type 2 diabetes increases by 50%. They experience higher rates of obesity, gastrointestinal disorders, and depression. Female shift workers have increased rates of breast cancer, as male shift workers have higher rates of prostate cancer, and the cognitive effects are permanent. Studies show that people who worked night shifts for 10 years or more show cognitive decline, equivalent to adding 6.5 years to their age. But here's what's truly disturbing. These effects don't immediately reverse when someone stops working nights. A study that followed former shift workers found that even after returning to normal schedules, they continued to show elevated disease risks for years. The damage to their circadian systems had created lasting changes in their biology. Now, let's discuss something that affects almost everyone, whether you work shifts or not: social jet lag. This term was coined by chronobiology researcher Till Roeneberg to describe what happens when your social schedule conflicts with your biological clock. Most people have a work schedule that forces them to wake up earlier than their body naturally wants. They spend the week sleep-deprived, accumulating sleep debt. Then on weekends, they sleep in, trying to catch up. This creates a pattern where your body experiences the equivalent of jet lag every single week. On Monday morning, waking up at 6 a.m. feels like waking up at 3 a.m. would if you'd just flown from Los Angeles to New York. Your body hasn't adjusted to the new schedule. Studies show that over 80% of working adults experience at least 1 hour of social jet lag, with many experiencing 2 or more hours. The health impacts of social jet lag are significant. Research published in the journal Current Biology found that each hour of social jet lag increases the risk of cardiovascular disease by 11%. People with 2 hours of social jet lag have a 33% increased risk of being overweight or obese. The constant weekly disruption to circadian rhythms creates metabolic dysfunction that promotes weight gain and disease. Here's a question for you. What time would you naturally wake up if you had no alarm clock, no obligations, and could just let your body decide? For many people, that time is significantly later than when they actually have to wake up for work or school. This mismatch between biological preference and social demands is creating a population of chronically jet-lagged individuals who never feel fully rested. Let's examine the role of caffeine in our modern sleep crisis. Americans consume an average of 3 cups of coffee per day, and that doesn't include energy drinks, tea, or caffeinated sodas. Caffeine works by blocking adenosine receptors in your brain. Remember, adenosine is the chemical that builds up during wakefulness and creates sleep pressure. Caffeine doesn't give you energy. It just blocks the signal that you're tired. But here's the problem. Caffeine has a half-life of about 5 to 6 hours in the average adult. This means if you drink a cup of coffee at 4 p.m., and half of that caffeine is still in your system at 10 p.m., even if you manage to fall asleep, the caffeine in your system reduces the quality of your sleep, particularly decreasing deep sleep. You might get 8 hours in bed, but you're not getting 8 hours of restorative sleep. A study from the Journal of Clinical Sleep Medicine found that consuming caffeine even 6 hours before bedtime reduced total sleep time by over 1 hour. But here's what's insidious. The subjects didn't feel like their sleep was worse. They didn't realize the caffeine was affecting them. This is the trap many people fall into. They drink caffeine throughout the day because they're tired from poor sleep. But the caffeine itself is contributing to the poor sleep, creating a vicious cycle. Now, let's talk about alcohol, because many people use it as a sleep aid. Alcohol does make you drowsy and can help you fall asleep faster, but it fundamentally disrupts sleep architecture. Alcohol suppresses REM sleep during the first half of the night. Then, as the alcohol metabolizes, you experience a REM rebound in the second half, leading to more frequent awakenings and lighter sleep. The result is fragmented, unrestorative sleep. Research shows that even moderate drinking, 2 drinks for men, 1 for women, significantly impairs sleep quality. Heavy drinkers often develop a condition called alcoholic insomnia, where they can't fall asleep without alcohol, but can't sleep well with it either. And here's something many people don't know. Alcohol withdrawal, even mild withdrawal in daily drinkers, causes severe insomnia that can persist for weeks or months. Temperature is another factor we've completely disrupted in modern life. Your body temperature needs to drop by about 2 to 3 degrees Fahrenheit to initiate sleep. This is why it's easier to sleep in a cool room. But modern homes are often kept too warm, especially bedrooms. The optimal temperature for sleep is between 60 and 67 degrees Fahrenheit. Yet most people keep their thermostats set much higher. Additionally, taking a hot shower or bath right before bed, which many people do, can actually delay sleep onset because it raises your core body temperature. The better approach is to take a warm bath 90 minutes before bed. As your body cools down after the bath, it triggers sleepiness. But most people don't know this and unintentionally sabotage their sleep. Let's discuss the economics of sleeplessness, because this epidemic has a massive financial cost. The Rand Corporation published a comprehensive study estimating that insufficient sleep costs the U.S. economy $411 billion annually. That's more than the GDP of many countries. The costs come from reduced productivity, increased accidents, higher healthcare expenses, and premature mortality. Workers who sleep less than 6 hours per night are significantly less productive, make more errors, and have higher rates of absenteeism. The American Academy of Sleep Medicine estimates that workplace accidents caused by sleepiness cost $75 billion per year. Drowsy driving causes an estimated 6,000 fatal crashes annually in the United States alone. But beyond the economics, there's a human cost that's harder to quantify. Sleep-deprived parents are less patient with their children. Sleep-deprived partners have more relationship conflicts. Sleep-deprived individuals experience less joy, creativity, and connection with others. They're more likely to develop depression and anxiety. The quality of life impacts of chronic sleep deprivation are profound and pervasive. Here's something that should shock you. We've normalized extreme sleep deprivation to the point where it's become a status symbol. Entrepreneurs brag about getting 4 hours of sleep. Medical residents are expected to work 30-hour shifts. Investment bankers compete over who sleeps least. We've created a culture where sacrificing sleep is seen as dedication, and sleeping adequate amounts is seen as lazy or weak. This is insane. We would never brag about smoking cigarettes or eating fast food for every meal. We recognize those behaviors as unhealthy, but we glorify sleep deprivation despite overwhelming evidence that it's just as damaging to health. The message needs to change. Adequate sleep isn't a luxury or a sign of weakness. It's a biological necessity that determines your health, longevity, and quality of life. Let me give you some perspective on how abnormal our current situation is. For the vast majority of human history, people slept when it got dark and woke when it got light. They didn't have alarm clocks. They didn't have artificial light. Their sleep was synchronized with their environment. Studies of indigenous populations still living traditional lifestyles show they sleep an average of 7 to 8.5 hours per night, with sleep schedules that vary naturally with the seasons. Compare that to modern Americans, where 40% report sleeping less than 7 hours per night, where 1 in 3 adults has insomnia, where sleeping pills are a $10 billion industry, where children are increasingly diagnosed with sleep disorders. We've created an environment so hostile to sleep that our biology is constantly fighting against our lifestyle, and it starts young. School start times are a perfect example of how we ignore biology in favor of convenience. Teenagers' circadian rhythms naturally shift later during puberty. Their brains release melatonin later at night and take longer to clear it in the morning. They're biologically programmed to stay up later and wake up later. Yet most high schools start at 7:30 or 8 a.m., forcing teenagers to wake up when their brains are still in sleep mode. Studies show that when school start times are delayed by even 30 minutes, students show improved academic performance, better mental health, lower rates of car accidents, and reduced tardiness and absenteeism. Yet most schools refuse to change start times, citing logistics and tradition. We're literally sacrificing our children's health and academic success because we've always done it this way. The modern epidemic of sleeplessness isn't just about individual choices. It's structural, it's cultural, it's embedded in how we've organized society. We've created 24-hour economies that require people to work at all hours. We've built cities flooded with artificial light. We've developed technologies specifically designed to capture attention and keep us engaged regardless of the hour. We've glorified productivity over health and busyness over rest. And the consequences are playing out in our collective health statistics. Rates of obesity, diabetes, cardiovascular disease, depression, and anxiety are all rising, and chronic sleep deprivation is a contributing factor to all of them. We're literally making ourselves sick by refusing to sleep. Here's what frustrates me most. We have the knowledge. Sleep science has advanced tremendously in the past few decades. We understand the mechanisms. We know what works and what doesn't. We can see the damage that sleep deprivation causes. But that knowledge hasn't translated into cultural change. We continue to treat sleep as expendable, to prioritize everything else over rest, to run ourselves into the ground in pursuit of productivity and success. But what if I told you that recovery is possible? What if the damage we've discussed, the compromised immune systems, the metabolic dysfunction, the cognitive decline, what if it could be reversed? Not overnight and not without effort, but genuinely improved through consistent, adequate sleep. Because while we've spent this entire journey through the darkness of sleeplessness, there's something we haven't fully explored yet: the science of recovery, the protocols that actually work, and the profound question of whether you can truly pay back the sleep debt you've accumulated. A 42-year-old woman named Sarah came to a sleep clinic in 2019 after 15 years of chronic insomnia. She had been sleeping 4 to 5 hours per night since her late 20s, functioning on caffeine and willpower. She'd tried every sleeping pill on the market. Nothing worked. She was overweight, pre-diabetic, anxious, and increasingly forgetful. Her doctor told her bluntly, "Your biological age is 58. Your chronological age is 42. You've aged 16 years faster than you should have because of sleep deprivation." Sarah broke down crying. But then her doctor said something that changed everything. "But if you commit to fixing your sleep, we can reverse much of this damage. Your body wants to heal. You just have to give it the chance." 18 months later, Sarah had lost 30 pounds. Her blood sugar was normal, her anxiety had diminished, and her cognitive tests showed significant improvement. She looked and felt a decade younger. The question is, can recovery really happen? Or is the damage from years of poor sleep permanent? If you're wondering whether you can undo the damage from all those sleepless nights, hit that like button and subscribe, because we're about to explore the science of sleep recovery and discover that your body has more healing capacity than you might think if you know how to activate it. Let's start with the most common question people ask: can you catch up on sleep? The answer is more nuanced than a simple yes or no. In the short term, yes, you can recover from acute sleep deprivation. If you pull an all-nighter, sleeping extra the following night will restore most of your cognitive function. Studies show that after one night of total sleep deprivation, 2 nights of recovery sleep are usually sufficient to return to baseline performance. But chronic sleep deprivation is different. If you've been sleeping 6 hours a night for years when you need 8, you've accumulated what researchers call sleep debt. A landmark study by researchers at the Walter Reed Army Institute of Research found that this debt doesn't simply disappear with a few good nights of sleep. They restricted subjects to 6 hours of sleep per night for 2 weeks, then gave them recovery sleep. It took 3 full weeks of unrestricted sleep, sleeping as long as they wanted every night, before cognitive performance fully returned to baseline. 3 weeks to recover from 2 weeks of restriction. That's a sobering ratio. And that's only 2 weeks. What if you've been sleep deprived for years, decades? The research suggests that while significant recovery is possible, it requires sustained commitment and can take months or even years to fully reverse the accumulated damage. Here's what we know about the recovery process. When chronically sleep-deprived individuals finally get adequate sleep consistently, measurable improvements begin within days. Brain imaging studies show that after just 1 week of sleeping 8 hours per night, activity in the prefrontal cortex begins to normalize. The amygdala becomes less hyperactive. The hippocampus shows improved connectivity. Your brain starts healing almost immediately once you give it the rest it needs. Metabolic improvements take a bit longer, but are equally dramatic. A study published in the Annals of Internal Medicine examined healthy adults who were restricted to 5.5 hours of sleep per night. Their insulin sensitivity decreased by over 30%, pre-diabetic levels, but when they were allowed to sleep 8.5 hours per night, insulin sensitivity returned to normal within just 2 weeks. The metabolic damage was reversible, Immune function recovery is similarly encouraging. Research shows that after chronic sleep restriction, just 3 consecutive nights of adequate sleep can restore natural killer cell activity to normal levels. Your immune system bounces back faster than you might expect, which is why getting good sleep when you're sick is so effective at helping you recover. But not all damage is reversible. Studies of long-term shift workers show that some effects persist even after returning to normal sleep schedules. Cardiovascular changes, in particular, seem to have lasting impacts. Years of elevated blood pressure and chronic inflammation can cause permanent damage to blood vessels and heart tissue. The good news is that the risk stops increasing once you resume healthy sleep patterns. The bad news is that some of the accumulated damage remains. So, what actually works for improving sleep? Let's start with what doesn't work, because there are a lot of misconceptions out there. Sleeping pills are the most common intervention, and they're largely ineffective for long-term sleep improvement. Most prescription sleep medications, things like Ambien, Lunesta, or benzodiazepines, don't produce natural sleep. They produce a sedated state that looks like sleep, but lacks many of the restorative properties of genuine sleep. Brainwave studies show that people taking sleeping pills have altered sleep architecture. They get less deep sleep and less REM sleep, the most restorative stages. They wake up feeling groggy and often develop tolerance, requiring higher doses for the same effect. And when they try to stop, they experience rebound insomnia that's often worse than their original sleep problem. Sleeping pills can be useful for short-term situational insomnia, but they're not a solution for chronic sleep problems. Over-the-counter sleep aids like Benadryl or Tylenol PM work by blocking histamine, which makes you drowsy, but they also impair memory consolidation, reduce REM sleep, and can cause morning grogginess and cognitive impairment. Studies show that regular use of antihistamines for sleep is associated with increased risk of dementia in older adults. They're not the harmless solution many people think they are. Alcohol, as we discussed earlier, is one of the worst things you can do for sleep quality despite making you feel sleepy. It fragments sleep, suppresses REM, and creates a rebound effect that causes early morning awakening. If you're using alcohol to sleep, you're not actually solving your sleep problem. You're making it worse. So, what does work? The gold standard treatment for chronic insomnia is cognitive behavioral therapy for insomnia, or CBTI. This is a structured program that addresses the thoughts and behaviors that perpetuate sleep problems. Multiple studies show that CBTI is more effective than sleeping pills for long-term improvement, with benefits that persist for years. CBTI involves several components. The first is sleep restriction, which sounds counterintuitive but is remarkably effective. If you're spending 8 hours in bed but only sleeping 5, you're training your brain to associate bed with wakefulness. Sleep restriction involves limiting time in bed to match actual sleep time. So if you're sleeping 5 hours, you'd only allow yourself 5 hours in bed. This creates sleep pressure that makes it easier to fall asleep and stay asleep. Once sleep efficiency improves, you gradually increase time in bed. A study published in the Journal of the American Medical Association compared CBTI to Ambien. After 8 weeks, CBTI was significantly more effective. After 6 months, people who'd received CBTI were still sleeping well, while those who'd taken Ambien had returned to baseline or worse. The behavioral changes created by CBTI produce lasting improvements that medication simply cannot match. Another critical component is stimulus control. This means using your bed only for sleep and sex. Nothing else. No reading, no TV, no phone, no worrying. You want your brain to associate bed with sleep, not wakefulness. If you can't fall asleep within 20 minutes, you get up and do something relaxing in another room until you feel sleepy again. This breaks the association between bed and frustration or anxiety. Light exposure is another powerful tool that most people underutilize. Remember, light is the primary signal that entrains your circadian rhythm. Getting bright light exposure in the morning, ideally sunlight, but bright artificial light works too, helps set your body clock. A study from Northwestern University found that workers who had windows and received natural light during the day slept an average of 46 minutes more per night than those who worked in windowless environments. Conversely, dimming lights in the evening signals to your brain that sleep time is approaching. This doesn't just mean turning off screens, though that's important. It means reducing overall light levels in your home for the 2 hours before bed. Using amber-tinted glasses that block blue light can be helpful if you must use screens in the evening. Research shows these glasses can increase melatonin production by 58% compared to unfiltered screen exposure. Temperature manipulation is another evidence-based strategy. As mentioned earlier, your body needs to cool down to initiate sleep. Taking a warm bath 90 minutes before bed causes your body to cool more rapidly afterward, facilitating sleep onset. Keeping your bedroom cool, ideally between 60 and 67 degrees, helps maintain the lower body temperature needed for deep sleep. Some people find that wearing socks to bed helps because warming your extremities causes blood vessels to dilate, which actually cools your core body temperature. Exercise is powerful for sleep improvement, but timing matters. Morning or afternoon exercise improves sleep quality that night by increasing sleep pressure and regulating circadian rhythms. But vigorous exercise within 2 to 3 hours of bedtime can be counterproductive because it raises body temperature and cortisol levels. If evening is your only exercise option, gentle activities like yoga or walking are better choices than high-intensity workouts. Diet impacts sleep in ways many people don't realize. Eating large meals close to bedtime impairs sleep because your digestive system is active when it should be resting. But going to bed hungry isn't good either. A light snack containing both carbohydrates and protein, like toast with peanut butter or yogurt with berries, can actually improve sleep by stabilizing blood sugar and providing tryptophan, a precursor to melatonin and serotonin. Caffeine deserves special attention because people dramatically underestimate its impact. If you're having any sleep difficulties, eliminating caffeine after noon is a simple change that can make a dramatic difference. Some people need to stop even earlier. Remember, caffeine has a half-life of 5 to 6 hours, but it takes much longer to completely clear from your system. That afternoon, coffee is still affecting you at bedtime. Stress management is crucial because anxiety and worry are primary drivers of insomnia. Techniques like progressive muscle relaxation, meditation, or deep breathing can activate your parasympathetic nervous system, your rest and digest mode, and counteract the stress response that keeps you awake. A meta-analysis of mindfulness-based interventions for insomnia found significant improvements in sleep quality and duration. One particularly effective technique is called constructive worry time. Instead of lying in bed worrying, you set aside 15 minutes earlier in the evening to write down your worries and potential solutions. This gives your brain permission to set those concerns aside at bedtime because you've already addressed them. Studies show this simple intervention can reduce the time it takes to fall asleep by an average of 30 minutes. Now, let's talk about melatonin supplements because there's a lot of confusion about them. Melatonin is not a sleeping pill. It's a timing signal. Taking melatonin tells your brain, it's nighttime now. It can be useful for shifting your circadian rhythm. For instance, if you're trying to adjust to a new time zone or reset a disrupted schedule. but it's not particularly effective as a direct sleep aid. The research shows that melatonin reduces the time it takes to fall asleep by an average of 7 minutes. 7 minutes. That's not nothing, but it's not the dramatic effect many people expect. Where melatonin can be helpful is for people whose circadian rhythms are severely disrupted, like shift workers or people with delayed sleep phase disorder. But for garden variety insomnia, behavioral interventions are far more effective. Let me share another recovery success story that illustrates these principles. A 55-year-old man named Robert had worked night shifts as a security guard for 20 years. His health had deteriorated significantly. He was obese, diabetic, hypertensive, and chronically exhausted. When he retired and switched to a normal sleep schedule, he expected to immediately feel better. Instead, he experienced severe insomnia. His circadian rhythm was so disrupted that he couldn't fall asleep at night, even when he was exhausted. Robert worked with a sleep specialist who implemented a chronotherapy protocol. This involved gradually shifting his sleep time earlier by 1 hour every few days until he reached a normal schedule, combined with strict light exposure timing, bright light in the morning, complete darkness at night, and CBTI techniques. His circadian rhythm slowly normalized over about 3 months. His sleep quality improved dramatically, and over the following year, his metabolic markers improved, his blood pressure normalized, and he lost over 40 pounds without consciously dieting. His body healed once it finally received the sleep it had been denied for decades. Here's something important to understand. Sleep recovery isn't linear. You won't feel incrementally better each day. Instead, improvement happens in waves. You might have a week of great sleep followed by a few rough nights. This is normal. What matters is the overall trend over weeks and months. Your body is recalibrating complex biological systems, and that takes time. One common mistake people make when trying to improve sleep is becoming obsessed with tracking it. Sleep tracking devices and apps can provide useful information, but they can also create anxiety about sleep that makes insomnia worse. If you're lying in bed worried about whether you're getting enough deep sleep or REM sleep, you're creating stress that interferes with sleep. Use tracking tools as general guides, not as precise measurements to obsess over. Another mistake is having unrealistic expectations. You're not going to go from chronic insomnia to perfect sleep overnight. Recovery is a process. Celebrate small improvements. If you used to lie awake for 2 hours and now it's only 45 minutes, that's progress. If you used to wake up 5 times per night and now it's only 2, that's improvement. Don't let perfect be the enemy of better. The most important thing to understand about sleep recovery is this. Your body wants to heal. Given the right conditions, consistent sleep opportunity, proper light exposure, stress management, good sleep hygiene, your brain and body will move toward health. Evolution has built powerful healing mechanisms into your biology. You just have to stop interfering with them. But even with all this knowledge about recovery, there's still one fundamental question we need to address. After everything we've explored, the fatal consequences of total sleep loss, the biological collapse that follows deprivation, the modern epidemic stealing our rest, how do we actually know when we've crossed the point of no return? Is there a moment when the damage becomes irreversible? And more urgently, how do you know if you're approaching that threshold right now? Because understanding the warning signs and the ultimate limits of sleeplessness isn't just academic curiosity. It might be the most important information you need to protect your health and your life. There's a moment in every sleep deprivation study where researchers have to make a difficult decision: when to stop. How long can they ethically keep someone awake before the risk becomes too great? In Randy Gardner's 11-day experiment back in 1964, Researchers were constantly monitoring for signs of irreversible damage. They had a threshold in mind, a point beyond which they would end the study regardless of Randy's willingness to continue. That threshold was based on one critical question that haunts sleep science to this day. Is there a point of no return? A moment when sleep deprivation crosses from reversible impairment to permanent damage? And if that threshold exists, how close are you to it right now? If you've made it this far in our journey through the science of sleeplessness, thank you for staying with me. Hit that like button one more time and make sure you're subscribed, because we're about to answer the most important question of all. How do you know if you're in danger, and what can you do about it before it's too late? Let's start with the most extreme case we know of, the world record for voluntary sleep deprivation. After Randy Gardner's 11 days in 1964, Guinness Book of World Records stopped accepting attempts for this record because they deemed it too dangerous. But in 2007, a British man named Tony Wright claimed to have stayed awake for 11 days and 16 hours, breaking Gardner's record. However, his attempt was not scientifically monitored, and skeptics believe he likely experienced numerous micro-sleeps that he wasn't aware of. The longest scientifically verified and monitored sleep deprivation is still Randy Gardner's 264 hours. And here's what's crucial. Even at that extreme, Randy recovered. After sleeping for 14 hours, he was remarkably close to normal. Follow-up studies decades later showed no lasting cognitive damage attributable to those 11 sleepless days. This suggests that even extreme acute sleep deprivation, while temporarily devastating, may not cause permanent harm if followed by adequate recovery. But animal studies tell a more sobering story. In the 1980s, researcher Alan Rechtschaffen at the University of Chicago conducted experiments where rats were kept awake using a rotating platform. Whenever the rats' brain waves indicated they were falling asleep, the platform would rotate, forcing them to walk to avoid falling into water. The results were shocking. Every single rat died within 11 to 32 days. None survived. The autopsy showed multiple organ failures, severe immune suppression, and dramatic weight loss despite increased food consumption. Total sleep deprivation was 100% fatal. Now, humans are not rats, and ethics prevent us from conducting similar experiments on people. But the rat studies revealed something important. There appears to be a biological limit to how long a mammalian body can survive without sleep. For rats, that limit is about 2 to 3 weeks. For humans, we don't know exactly, but case studies suggest it's likely similar or slightly longer. Remember Michael Cork, the man with fatal familial insomnia we discussed at the beginning? He survived 6 months from first symptoms to death, but he wasn't experiencing total sleep deprivation for all that time. In the early stages, he was getting fragmented, poor quality sleep. It was only in the final months that sleep became completely impossible. This suggests that even partial sleep, brief moments of dozing, micro-sleeps, light stage 1 sleep, provides enough biological support to extend survival beyond what total sleep deprivation would allow. But here's where it gets personal for all of us. You're probably not going to die from acute total sleep deprivation. What you need to worry about is chronic partial sleep deprivation. Getting 6 hours when you need 8, 5 hours when you need 7, year after year after year. This is where the point of no return becomes relevant for everyday people. Research published in the journal Sleep examined the long-term effects of chronic sleep restriction. They found that consistently sleeping less than 6 hours per night for extended periods, we're talking years, not weeks, creates cumulative damage that may not be fully reversible. Brain imaging studies show that chronic sleep deprivation is associated with reduced gray matter volume in the frontal cortex, temporal lobes, and hippocampus. These are brain regions critical for decision-making, memory, and emotional regulation. The terrifying question is this brain shrinkage reversible? Some studies suggest partial recovery is possible with sustained sleep improvement, but other research indicates that severe, prolonged sleep deprivation may cause permanent structural changes. We don't have definitive answers yet because the research is ongoing. But what we do know is that the longer you wait to address sleep problems, the harder recovery becomes, and the more likely you are to have lasting effects. So, how do you know if you're at risk? Let me give you a practical assessment that's based on clinical sleep medicine. Ask yourself these questions honestly. Do you need an alarm clock to wake up on weekdays? If yes, you're probably not getting enough sleep. A well-rested person wakes naturally around their body's preferred time. Do you hit the snooze button? That's a sign of significant sleep debt. Your body is desperately trying to get more sleep. Do you feel drowsy during the day? Not just slightly tired, but actually struggling to stay awake during activities like reading, watching TV, or sitting in meetings? That's a red flag. Do you fall asleep within 5 minutes of lying down at night? Contrary to popular belief, this isn't a sign of being a good sleeper. It's a sign of severe sleep deprivation. A healthy person should take 10 to 15 minutes to fall asleep. Falling asleep instantly means you're so sleep deprived that your brain is shutting down the moment you give it permission. Do you sleep significantly longer on weekends than weekdays? If you're sleeping 2 or more hours extra on weekends, you're accumulating dangerous sleep debt during the week. Do you rely on caffeine to function? If you need multiple cups of coffee just to feel awake, your body is trying to tell you something. Do you make impulsive decisions or have trouble controlling your emotions? Sleep deprivation impairs the prefrontal cortex, making impulse control and emotional regulation difficult. Here's a particularly telling question. Can you remember the last time you woke up without an alarm clock feeling genuinely refreshed and alert? Not just okay, but truly energized and ready for the day? If you can't remember when that happened, you're chronically sleep deprived and you've been living in a degraded state for so long that you've forgotten what normal feels like. One of the most insidious aspects of chronic sleep deprivation is that you lose the ability to judge how impaired you are. Studies consistently show that sleep-deprived individuals rate their performance much higher than objective tests indicate. You might think you're functioning at 80% when you're actually at 50%. This is why people who chronically sleep poorly often don't realize how much better they could feel. Let me share one final story that brings all of this together. A neuroscientist named Dr. Matthew Walker, who directs the Center for Human Sleep Science at UC Berkeley, spent decades studying sleep. In his research, he saw countless brain scans showing the damage that sleep deprivation causes. He saw the epidemiological data linking poor sleep to disease and early death. And then, one day, he looked at his own sleep habits. He was sleeping 6 hours per night, sometimes less, believing he was fine because he was used to it. He decided to conduct a personal experiment. For 3 months, he committed to sleeping 8 hours per night, no exceptions. He tracked his mood, cognitive performance, and health markers. What he found shocked him. His memory improved dramatically. His reaction time quickened. His mood stabilized. He realized he'd been living in a fog for years without knowing it. Most remarkably, several minor health issues he'd attributed to aging, frequent colds, afternoon energy crashes, difficulty concentrating, all resolved. He'd been 50 years old feeling like 60. After 3 months of proper sleep, he felt 45. Dr. Walker now calls sleep the single most effective thing you can do to reset your brain and body health. Coming from someone who's dedicated his career to studying every aspect of sleep science, that's a powerful statement, and he's right. No supplement, no medication, no biohack can match what adequate sleep does for your health. But here's what gives me hope, and what I want to leave you with. Your body is extraordinarily resilient. The damage we've discussed throughout this video, the immune suppression, the cognitive impairment, the metabolic dysfunction, the accelerated aging, much of it can be reversed. Not overnight, not without effort, but genuinely, measurably reversed through consistent, adequate sleep. Think about what we've learned on this journey. We started with Michael Cork and fatal familial insomnia, a disease that proves sleep is not optional. It's as essential to life as oxygen. We explored the cellular mechanisms of sleep deprivation, watching Randy Gardner's brain struggle through 11 days without rest. We descended into the torture chambers where sleep deprivation was weaponized to break minds. We witnessed Peter Tripp's hallucinations as reality dissolved around him. We examined the immune collapse and biological deterioration that follows sleep loss. We met the family's curse by FFI, facing genetic death sentences. We confronted the modern epidemic, stealing sleep from millions. And we discovered that recovery is possible if you take action. The question isn't whether sleep matters. The science has answered that definitively. The question is, what are you going to do about it? Will you continue sacrificing sleep for work, for entertainment, for the illusion of productivity? Or will you recognize that sleep is the foundation upon which everything else in your life is built? Here's my challenge to you. For the next 2 weeks, prioritize sleep above everything except true emergencies. Get to bed at the same time every night. Give yourself an 8-hour sleep opportunity. Turn off screens an hour before bed. Keep your room cool and dark. See what happens. Pay attention to how you feel, how you think, how you interact with others. You might be shocked by how much better life can be when you're actually well rested. And here's the most important thing I want you to remember. You are not weak for needing sleep. You are not lazy for prioritizing rest. You are not less dedicated or ambitious because you sleep 8 hours. You're human. And humans need sleep the way we need food, water, and air. It's biology, not a character flaw. The body that never sleeps is a body that's dying. But the body that sleeps well is a body that can heal, grow, thrive, and achieve everything you're capable of. Your brain deserves rest. Your body deserves recovery. You deserve to feel what it's like to be fully, genuinely, healthily awake. So here's what I want you to do right now. Think about what time you need to wake up in the morning. Count back 8 hours. That's your bedtime. Not your start getting ready for bed time. Your lights off, phone away, actually trying to sleep time. It's that simple. Not easy, but simple. And if you've been struggling with sleep for years, if nothing seems to work, if you've tried everything, please talk to a sleep specialist. Chronic insomnia is a medical condition with evidence-based treatments. You don't have to suffer through it. CBTI has a success rate of 70 to 80%. Recovery is possible. Before we end, let me ask you one final question. Knowing everything you now know about what sleep deprivation does to your brain, your body, your health, and your life, knowing that it can kill you, age you, impair you, and steal years from your lifespan, will you make a different choice about sleep tonight? Because that's all it takes to start changing your life. One choice, one decision to prioritize rest. One night of treating sleep as the non-negotiable biological necessity that it is. Thank you so much for joining me on this deep dive into the science of sleep and sleeplessness. I know it's been intense. We've covered some dark territory, but I hope you're walking away with a profound appreciation for just how precious and important sleep is. Your body performs miracles while you sleep. Clearing toxins, consolidating memories, strengthening immunity, repairing DNA, regulating metabolism. Don't deprive yourself of those miracles. If you enjoyed this video and learned something valuable, please share it with someone who needs to hear this message. We all know people who are sacrificing sleep, who are running themselves into the ground, who are suffering from chronic exhaustion. Send them this video. It might change their life. And stay tuned because we have so many more fascinating topics to explore together here on Sleepy Science. From the mysteries of dreams to the cutting edge of sleep technology, from ancient sleep practices to the future of rest. We're going to continue this journey into understanding one of the most essential and mysterious aspects of human existence. Until next time, I want you to remember, sleep isn't a luxury. It's not a weakness. It's not time wasted. Sleep is the foundation of everything you are and everything you can become. Treat it with the respect and priority it deserves. Now, if you'll excuse me, after spending the last hour and 45 minutes talking about sleep deprivation, I think I need a nap. Sweet dreams, everyone, and thank you for being here with me.